Okay, so we just looked at solving trigonometric equations, and we're going to use some of the ways that we solve those trigonometric equations to help us in this next section, which is showing that identities hold true or established identities. And the objectives are in front of us. We're going to use algebra to simplify the expression, and we're going to establish identities. And so it's helpful for us to just kind of recall some of those identities, main identities that you should know from the beginning of the semester. So recall that we have our quotient identities, so we could rewrite tangent theta and cotangent theta in terms of sine and cosine theta. So tangent theta is sine theta over cosine theta, cotangent theta is cosine theta over sine theta. You should also know your reciprocal identities, that cosecant theta, secant theta, and cotangent theta can be rewritten as respectively cosecant theta is 1 over sine theta, secant theta is 1 over cosine theta, and cotangent theta is 1 over tangent theta. We then looked at our Pythagorean identities, and we improved this or saw these by looking at the triangle and using the Pythagorean theorem. We saw that sine squared theta plus cosine squared theta equals 1. We can get the other two identities by either dividing through every term by sine squared theta. If we did that, we'd have sine squared theta divided by sine squared theta is 1. Cosine squared theta divided by sine squared theta is cotangent squared theta equals 1 over sine squared theta, which is cosecant squared theta. So that's that bottom one right here. And we could get that one to the right of our main Pythagorean identity by dividing everything through by cosine squared theta. So sine squared theta divided by cosine squared theta, that gives us our tangent squared theta, plus cosine squared theta divided by cosine squared theta gives us a plus 1 equals 1 over cosine squared, which is secant squared theta. So as long as you know that sine squared theta plus cosine squared theta equals 1, we can get those other two by either dividing everything through by cosine squared theta or sine squared theta. Other thing is that you need to be able to notice some sort of form of these identities. So for instance, and we were using this when we were solving the trigonometric equations, we could isolate one of those trig functions, like sine squared theta we saw was the same thing as 1 minus cosine squared theta. Or cosine squared theta is the same thing as 1 minus sine squared theta. So when we're proving these identities, which we haven't really gotten to yet, sometimes we're going to need to use these identities to help us solve. So same sort of idea, we can manipulate the following ones over here by, subtracting tangent squared theta. So we know secant squared theta minus tangent squared theta. It's the same thing as 1. We could subtract cotangent squared theta. So cosecant squared theta minus cotangent squared theta is equal to 1. So we can manipulate these to look like different forms. We also use the fact about even and odd identities to help us when we're looking at those trigonometric equations. We know that sine is odd. So sine of negative theta is negative sine theta. Cosecant theta is odd. Cosecant of negative theta equals negative sine theta. Cosine was an even function, so cosine of negative theta was cosine of theta. Secant was also even. Secant of negative theta equals secant of theta. And tangent and cotangent were odd, so cotangent of negative theta equals negative cotangent theta, and tangent of negative theta equals negative tangent theta. So algebra techniques that we'll be using to help us when we're looking at these identities and showing that an identity is true or not. So there's 4 basic algebra techniques that are used to establish our identities. So these identities that we're going to look at, sometimes we won't know what route to go, and we just need to start trying things, and hopefully they will fall out really nicely. And things that will help us to get things to fall out really nicely are the following. So rewriting trigonometric expressions just in terms of sine and cosine. We could multiply the numerator denominator of a ratio by they call it a well-chosen one. I kind of call it a special one. So maybe multiplying by the conjugate of the two terms, both in the numerator and denominator. Rewriting sums of trigonometric ratios as a single ratio. And then factoring could also be helpful. Okay, so those are some algebra techniques that we're going to use when we start looking at these identities. And then we have some guidelines to help us. So the guidelines that are going to help us. It's almost always preferable to start with a side of containing the more complicated expression. When we're working with these identities, we're only working with one side of the equation. When we were solving equations, we can move things over left and right, and we would isolate and try to solve for a variable. That's different when we're establishing identities. You're only working on one side of the equation. We're trying to manipulate it to look like the other side. And once we've done that, we're done. So another guideline is rewrite sums or differences of quotients as a single quotient. So if you have multiple fractions in there, maybe rewriting it as a single fraction would be helpful. Sometimes it helps us to rewrite one side in terms of sine and cosine function only, which we talked about when we were looking at the algebra techniques. And always keep the goal in mind. As you manipulate one side of the expression, keep in mind the form of the expression on the other side. Okay, so these are kind of fun, and they can get a little tedious, or they can get, sometimes you just have to go through and try different routes and see if things will fall out. Sometimes you'll go down different rabbit holes that won't take you anywhere, and you just have to restart over. So let's jump in and look at some examples. Okay, so we want to show the following identity is true, and it has sine theta all times the quantity cotangent theta plus tangent theta is equal to secant theta. So again, when we're working with these identities, you choose one side to work on, and you're manipulating that one side to look like the other side. And so it's most beneficial, helpful to look at the more complicated side. So looking at this, my more complicated side is the left-hand side. So I'm going to make a note working on the left side. So we're just working on the left-hand side, which is sine theta all times cotangent theta plus tangent theta. So my goal here is to manipulate this to look like secant theta. And once I've done that, we're done. So one of the suggestions was, let's rewrite things in terms of sine and cosine. So maybe let's start by doing that. So we have sine theta all times, well, cotangent theta, that was the same thing as cosine theta, all over sine theta, plus tangent theta. Tangent was sine theta, all over cosine theta. So if we distribute our sine theta to both terms, well, sine theta all times cosine theta over sine theta plus we have sine theta all times sine theta over cosine theta. So I notice with that first grouping, I have sine theta in the numerator and I have sine theta in the denominator. So those things cancel and we're left with just cosine theta. Plus, here I notice that nothing cancels. And so sine theta times sine theta is sine squared theta all over cosine theta. So this hasn't really helped me much. It doesn't look like secant theta. One of the other tricks was rewriting, if you had a fraction or multiple terms, rewriting it as a single fraction. So let's try jumping in and doing that. So I need a common denominator, and it looks like my least common denominator is going to equal cosine theta. So I just need to multiply this first term by cosine theta over cosine theta. So if cosine theta times cosine theta is cosine squared theta, plus this sine squared theta, because I have a common denominator, I can write it as a single fraction, all over our least common denominator of cosine theta. I see my Pythagorean identity here. Cosine squared theta plus sine squared theta, that's just equal to 1. And so rewriting that cosine squared theta plus sine squared theta as 1 all over cosine theta. Yay, 1 over cosine theta is the same thing as secant theta, which I wanted to show. We got the other side of our equation. So mathematically, if we prove something, we can show that we proved it by making a square. You don't have to fill in your square, but I did. So we just showed what we wanted to show. Sine theta times that quantity cotangent theta plus tangent theta is equal to secant theta. So that was a good one because it used a lot of the techniques that it was talking about using to help us manipulate these to give us what we want. So our next example in front of us, we want to show the identity or establish the identity that 3 sine squared theta plus 4 cosine squared theta is equal to 3 cosine squared theta. So looking at the more difficult side, it looks like the left-hand side is more difficult. So let's just work on that side. So working on the left side. So I want to manipulate the left side, 3 sine squared theta plus 4 cosine squared theta to look like 3 plus cosine squared theta. So let's first rewrite this left-hand side just in terms of cosine squared theta. And so again, we know that cosine squared theta plus sine squared theta was equal to 1. So I can rewrite sine squared theta is the same thing as 1 minus cosine squared theta. So that would give us 3 times that quantity, 1 minus cosine squared theta plus 4 cosine squared theta. So now distributing our 3 to both terms in that parentheses, we have 3 times 1 is 3, minus 3 times cosine squared theta is 3 cosine squared theta, plus 4 cosine squared theta. So negative 3 cosine squared theta plus 4 cosine squared theta. Those are like terms, so we can add those. So 4 minus 3, that gives us a plus 1 cosine squared theta. we got this to look like the right-hand side of our equation. And so we established that identity. So maybe look at one more. So we have 1 minus sine squared theta all over 1 minus cosine theta. This is equal to negative cosine theta. Okay, so I'm trying to manipulate this to look like what I want. So there's a couple ways that we can start this. We could rewrite this as a single fraction. We could multiply by the conjugate of 1 minus cosine theta, multiply that second term by a fancy 1. And I know I'm going to work on the left-hand side. So if I got a common denominator, that 1, that least common denominator would be 1 minus cosine theta. So maybe let's try it that way. So 1 minus cosine theta all over 1 minus cosine theta minus sine squared theta all over 1 minus cosine theta. I notice I don't have any signs on the right-hand side, which I'm trying to get. And so let's rewrite again sine in terms of cosine. So we saw that sine squared theta was the same thing as 1 minus cosine squared theta. So we have 1 minus cosine theta minus, I'm going to rewrite this as a single fraction, the whole quantity 1 minus cosine squared theta, because that's what sine theta was, all over 1 minus cosine theta. So distributing our negative sign, we have 1 minus cosine theta minus 1 plus cosine squared theta all over 1 minus cosine theta. So combining like terms in my numerator, I have 1 minus 1, so those cancel out. And then I have cosine squared theta, just rewriting descending order of powers, minus cosine theta all over 1 minus cosine theta. So I notice that my numerator, we can factor out a cosine theta from both of those terms. So if we pull out a cosine theta from both of those terms, we're left with cosine theta minus 1 all over 1 minus cosine theta. So notice what's inside that parentheses, cosine theta minus 1. It's almost identical to 1 minus cosine theta. We're off by a negative 1. So if we factored out a negative 1 in the numerator, so negative cosine theta, pulling out a negative 1 here, that would give us 1 minus cosine theta, or negative cosine theta plus 1, and we could just rewrite the order. All over this 1 minus cosine theta. Our cosine, 1 minus cosine thetas cancel, and we're left with our negative cosine of theta, which is what we wanted to show. So we're done. Okay, so it just kind of takes some practice with these identities. You just, again, you just got to just kind of jump in, try to use some of those tricks to help us manipulate the one side to look like the other side. And it might take you just some getting used to kind of see how things would fall out nicely. So I will come back on Thursday and we will talk a little bit more about these trigonometric identities and looking at some more examples.